All right, welcome back, everyone. This is the 10th annual virtual residency workshop. It is Wednesday, June 26th, 2024, and we are in our early afternoon session, which is what do researchers need from CI facilitators? Our moderator is Nandan Tandon, so I'm going to hand it over to Nandan. Go ahead.
Thank you, Henry. I'm going to share my screen. So let's see. Does that work?
Looks great.
Okay. All right. Thank you, Henry. So let me start by welcoming everyone. So we have 5 people as a panelist. Let's start by introducing ourselves. I'll start. So my name is Nandan Tandon. I am a computational scientist at University of Central Florida. So it's essentially my role is to support research computing and be a facilitator at the Office of Research. So my background is from computational material science, and I have only recently made this transition to a facilitator from a full-time researcher. So this whole area is new for me. Until this point, I thought most of the users for the HPC systems were physics or chemistry. And now I realize in these, so my transition happened about 2 months ago. So until then, I thought physics and chemistry were the most of the users, but it turns out there are other users as well from humanities and social sciences as well. So I'm really interested to know what experiences you have had with other areas and how that has worked out for you. So I'll pass on we'll go alphabetically through the panel. So each one of you can unmute yourself and describe. So Abhishek, if you can go next.
Yeah, sure. Hello, everyone. I'm Abhishek. I'm Research Computing Facilitator at New Jersey Institute of Technology. So I've been CI Facilitator for almost half a year. I mostly help the researcher resolve the issues they encounter while using the cluster. I'm also responsible for installing and managing the software on the cluster. So prior joining as research computing facilitator, I did my PhD in computational fluid dynamics, where I had some experiences of using computing clusters and also compiling the code. So this experience actually helped me to help the researchers based on their need.
Hi, everyone. Nice to be here. Thank you for having me. My name is Ashley Stauffer. I'm in a little bit of a wonky role. I've since moved beyond research computing in some reorganization that's happened at Penn State. So I used to be with the Office of the Associate CIO for Research, working in research facilitation services. Now I'm a business analyst and project manager with the Office of Research Information Systems at Penn State, and I'm managing a research support transformation project. I work typically in the social sciences, so my experience is as a research project manager and facilitator in data-intensive social science teams, sometimes working on high-performance systems, but sometimes working in other systems. My experience is typically dealing with data storage issues, data security, and also data acquisition for sensitive data sets. Nice to be here.
Hi, my name is Clinton Hyder, and I'm a facilitator with Rice University's Center for Research Computing. I've been in that role for about 7 years now. I've been at Rice a little more than 20 years, and my background is mostly in Unix and Linux systems administration, user support, and IT infrastructure. I work with users of most of our shared core systems and still do a little, up until recently, have been still doing a little bit of systems administration work for what we call our field support systems, which are like faculty owned equipment. And so I kind of, I'm moving into a new role that's more focused on training and onboarding. But I've been doing that all along as well. So thank you all for having me today.
Michael?
Hi, everyone. I'm Michael Weiner. I'm a research scientist and research computing facilitator at Georgia Tech, part of the Partnership for an Advanced Computing Environment there. I've been here for 5 years, and my role is really to help researchers use our systems, most of the local ones on our campus, figure out how to use the system, sometimes install software for them, do training, communications, and outreach as well. I got into this field after being a user of advanced computing systems. I have a PhD in physics that focused on computational biophysics, the use of a lot of the national resources. In addition to my roles at Georgia Tech, I'm a part of Campus Champions and currently the chair of their leadership team. You may have heard some from Mike Renfro yesterday about that. And also involved with CARC, the Campus Research Computing Consortium, as co-chair of the Staff Workforce Development Interest Group.
Hello, everyone. I'm Tom Marseille. I'm at Washington and Lee University as a senior technology integration specialist in STEM. And my role is basically to work with our students and faculty on utilizing high performance computing resources and other areas that support various projects that they're doing. We're in a unique position where we're a very small undergraduate school. We're about 1,850 undergraduates. So as a small campus, we don't have some of the on-premise resources that other institutions have, but that gives us a little bit of flexibility because we're able to tap into resources like Access, as well as we do a lot of work in cloud computing with AWS.
Yeah. Thank you, everyone. So we can move on to the questions. And before we start this, I just want to say it for the first timers that, volunteering for this panel was kind of intimidating, but Henry gives out all the questions and the panel is fairly helpful in their experience. So you can always go forward with that. And it really helps to have the questions with us. So I just want to give a shout out to Henry and arranging this thing. All right. So moving on to the first question. So it's again, please chip in as you feel. In your experience, what are the top 3 things that researchers need from CI facilitators? And it would help to give if you know the background of the researcher, so to identify what area they're coming from.
Do you want a specific panelist to answer that? Or
No,
should
please go ahead. So you can go alphabetically or please just unmute yourself and go ahead. Yeah.
Okay, I can give one experience and I do want to provide the context that I'm not necessarily on. So if we think of the CARC like 5 facings model, there's the data facing, researcher facing, systems facing, strategy and policy facing, and systems facing. So I tend to be in the researcher facing and the data facing areas. So what that means is I'm typically working with the researchers and the data. Probably the area where I have the least experience is systems facing. So I have less awareness of like high performance computing systems or system administration. I have some high level understanding. So when I'm working with researchers, the problems that I'm typically running into are around data security, data access, and storage problems. And so typically we were dealing with issues with software not working on a cluster, for example, or trying to figure out where does a data request exist, like sit in one of the complex processes for research administration. And typically the researchers I was working with were in the social sciences as well. So in human development and family studies. So the top thing that they would need from me is usually like a status update. Where is the status of this thing? Why isn't this thing working on this system? Or who can I talk to figure out this problem? Those I think would be the three big issues that I was dealing with. In addition to any compliance reviews like human subjects research or institutional review board protocols. Usually it was just things getting stuck somewhere along the process and me having to nudge it forward.
I want to add a couple of things. One, most of the in our clusters, researchers need some assistance compiling the software. So because they were not aware that software or whether the software is already installed on the computing clusters as a module or not. So we provide some information if the if the software is already there, and if not, and sometimes user needs to add their own solver in the particular software. So in that case, they need to compile it by themselves because they don't have the permissions to change the change the files where the software is installed. So in that case, they need some help from the research computing facilitator to show them how to compile the code and how to compile them. And there are other things that we frequently get the information from the researchers. In terms of providing the help, that in our clusters we have wall time constraints. So for example, the researchers cannot run more than 3 days. So this actually implemented to provide fair share to all the users. So sometimes user don't know how to check pointing the data. So in that case, because most of the software, I guess they already have, for example, GrowMax or OpenFOAM or CP2K. So there's most of the software already have, but they were not aware that they can do the checkpointing. So they ask research computing facilitators help to show them how to do the checkpointing. And if their code doesn't support the checkpointing, then we need to provide the support. There are other third-party software there which can do checkpointing for them.
So I would say, sort of at the very high level, the three things that researchers need are how they get access to the resources, whether it's the cluster or something else, how they use the resources we support, in my case, mostly an HPC cluster, and adding the hard part of that is so it's useful for their research. The easy part, sometimes is how to use it. If they say, well, I need four GPUs, 2 CPUs, this much memory, how do I get that? How do I get the software? That's sometimes the easier part, although software not always. But sometimes the harder part is how is that actually to the point of being useful for their research if they don't know exactly what they need? And the third thing I would say is when to use or when not to use the cluster or the services that we offer in our center versus resources elsewhere, whether it's national resources, a local machine in their lab, something else that's most accommodating for their needs.
Yeah, I think I could relate to that last comment as well. That a lot of times is trying to fit the workflow to the right scale of computing, and in some cases, in our institution, we have a lot of faculty who own their own systems, and sometimes there's a desire to integrate their local compute systems with our shared core facilities. But I think others have mentioned that, data storage. I think data storage is the biggest thing that we probably deal with in our group, and having to expand storage resources for both sharing and sort of internal storage, archival and backup. And and those kinds of questions. We get a lot of volume from that. And then we also get a lot of requests usually from students, occasionally from staff members or postdocs, but usually graduate students who just need to be trained on the systems and learn how to use them, whether it's our high performance computing clusters or we have like a private cloud virtual machines that we spend a lot of time with students teaching them how to use them and how to integrate them into different workflows. And then sort of workflow design, we do a lot of that, trying to identify sort of how you move data through these different systems and how to best use those resources and look for ways of making things more efficient. We spend a lot of time with doing that. And so those are probably would be my top issues would be training workflows and data storage. And then probably GPUs. Everybody wants GPUs right now. So.
And I'll add, at a small institution like ours, one of the biggest challenges we have is just letting people be aware of all the different resources that are out there and help them navigate through all the different choices. Sometimes there's a expectation that they won't be able to do something, and they don't realize that we do have the level of support to be able to help them with their project. So a lot of it is just kind of connecting the dots and having them come to us with an idea and being prepared to offer them a variety of different solutions. Another big area that we run into on our campus, since we typically are needing to use someone else's resources, is where that funding is going to come from and giving people estimates on how much it might cost for their projects, and then working within budgets that they have. And it's really great having all of these access resources, because even when someone comes to me and says they have no budget, I can still get them started on a project and give them some options.
That's really nice to hear that you can give them options even if they don't have any budget. That's yeah. Yeah, just Abhishek, going back to something you said. So you mentioned that you can do this checkpointing thing with a third-party software. So this is for specific application, or these are fairly general third-party softwares which work with multiple softwares
So it's
applications.
depends on what kind of code they're running. If they are already using some popular type of software, for example, GrowMax or CP2K, they don't need any third-party software. But in some cases where they have some in-house code and they need to rely on some other third-party software, like we mentioned the researchers to use DMTCP, which is multi-thread checkpointing. I'm not sure about what DA. I guess I forgot. So it's called DMTCP. So we provide some training to the researchers that how they could use this DMTCP to checkpointing their data.
Yeah, thanks. I think we can go to the second question, and I'm trying to keep up with the chat, but I think people are sending in information. I may have missed any questions, so if somebody notices a question, please let me know.
And I'm managing it.
Okay, thanks.
Yeah, we're just
Thanks, Ash.
no questions so far, just chatting.
Okay, yeah. Oops, jumped the gun. So the next question is a follow-up. How do you address your top three things? And if you could give any examples, that, yeah.
I can go first. So I'm remembering or thinking back to, data storage, security, data acquisition, even like IRB compliance reviews, really, how do I address the top three things? So first, I am listening to the researcher, trying to empathize with them and understand like what is so when researchers kind of present themselves, there's like a couple of different layers, and you have to peel back the onion of what is the actual root problem that they're trying to answer. So sometimes they might come to you angry or a little bit frustrated or talking about how inefficient a system or process is, that at least they come to me with those problems. And so first I'm kind of listening to them and letting them address some of that frustration. But then I'm asking some maybe probing questions to understand like what is the actual problem that they're trying to address, and then who are the right people to connect them to answer that question. So again, like I'm not typically like in the systems or on the technical side of the house, so I'll reach out to colleagues who are more technical than I am, and I'll point the researcher to that direction, create a warm handoff, and make sure that that connection goes well. So really facilitating all those different connection points. And I saw some people in the chat saying like connecting the dots. So really when I'm addressing the main issues that researchers are coming with me with is usually building rapport with them, listening. Sometimes they're venting a little bit, giving them that space to vent. And then, trying to solve the problem.
I can add to that one more thing, what Ashley has mentioned that about researchers getting frustrated. So sometimes I see that researchers complaining about the cluster is not working, and then I asked more questions why the user thinks that it's not working and get the job details. And finally, it turns out that user probably not, while running the software, he did some mistakes. And that's why because and he didn't get this error message in the output or error message because he didn't mention something in the slum slum output or slum error. So there are the practices I think that we provide. I believe that researchers needs to be aware of. So for that we provided some training sessions, because when the researcher just getting an account in the HPC systems, probably they copied the slum configurations from somewhere else, and they probably did not modify that according to that particular cluster, and that probably gave them some kind of errors. So to address these problems, we provide some basic trainings to the users, what's the best practices for running the jobs, and etc., and how they can effectively utilizing the slum resources. We also we also have slum accounting for the users. For example, at particular, we have different types of quality of service. So at particular quality of service, users have each PI group has certain slum service unit. So sometimes we also getting complaints from the user that they're running out of service unit. And that's reason that's because the users, mostly the graduate students, they are not effectively utilizing the resources. So we also provide the training to them or guide how to how they can effectively utilize the resources so that they can keep track of their slum accounting.
Another approach that we use is we really try to find what the best solution is for a particular researcher and not necessarily push them to what we feel is the best overall solution. So a great example of that is we work with a lot of faculty members in humanities, and they may have never worked on a command line interface before. And so they want to be in an environment that has a nice GUI and a graphical interface that they feel comfortable with. Some of them don't even want to be outside of a Windows environment. So that's where we can leverage things like EC2 instances in Amazon, spin up a very high-powered Windows instance, or if they're willing to at least explore Linux a little, we can get them started on Jetstream and have them use some of the graphical interfaces there. But we find if we come to where they are, where they feel comfortable with technology, that helps to get them up and running, on their actual project and getting results faster. And our researchers very frequently can only do their research during the summertime. So we're always fighting that very tight time schedule.
I can speak a little bit to our storage strategy for how we deal with data storage, and I'm sure most of folks on this call are familiar with the Google Drive switcheroo that happened not too long ago, and that created some additional demand for storage, research data storage that was already, we were already kind of busting at the seams. And so we have a large centralized network attached storage device that we provide shares to of individual faculty members. And we, allow access to members of their lab and manage the permissions for them. And one of the things that's been kind of great about that is that it's given us an opportunity for our group to engage with folks who weren't traditional HPC, because that data storage need is all over in every discipline. So it's been really useful for us to develop some relationships, because you at least get to know sort of what their research looks like, what kind of data they're working with, what kind of size of data that they're working with. And, as part of that, we also have integration with we have a Globus license, so we use Globus internally to transfer data between our cluster and like our network attached storage. We call it research data facility. Um, and that's really useful. That's been really useful in a lot of different workflows. And then we also have the ability to integrate that with our private virtual machine pool, which can mount those centralized resources. So that's been a really useful tool. We were also very fortunate to get a grant to install an open storage network pod at Rice. And we're just getting going with that. We got it at the beginning of this year. And I think it's going to be incredibly useful for data sharing, and just general storage and different types of workflows. Um, and so on the storage side, we're making some progress, but we just don't have enough disk space. And I think, but we're in the process of acquiring some more storage. So we spend a lot of time with research storage, data storage in our group. We also spend a lot of time working with students. Our workshop schedule I think has been pretty lean. We typically do like hour long, kind of very introductory, these are our services kinds of things, and then maybe have more deeper dives into into specific services. But we're going to try to work out longer workshops and more in depth where we can really get into more technical details. A lot of the time we're just meeting one-on-one, via Zoom, or people come by our office hours and we'll sit down with them and talk them through the problem that they're trying to solve on the systems, and or to give them a general orientation if they aren't trying to solve a particular problem. And we spend a lot of time doing that. So we're hoping that we can kind of revamp our training program and make it more effective. I'm curious to know from other folks on the panel, from a training perspective, what your sort of sweet spot is in terms of getting people to attend and what the useful what a useful length of a workshop is, because I can never get enough information in an hour-long workshop, but I know scheduling them longer is difficult. We've had really good luck with software carpentries. We've held a few carpentries events on our campus, and that has been really, really great for us. So that's a way we've approached user training as well.
I agree with the points that have been made so far. I think I'd say to add, on the original question of how to address these top three things that researchers need, part of it is knowing what resources exist both on and off campus if you can't meet their needs. So sometimes that's going back and saying, well, this is maybe something we should offer in the future if we get funding for it going forward. But sometimes there's another solution that's not something you can offer them, but it's out there. And it's a very challenging thing to know what else is out there, but having some framework for that can be helpful, whether it's directing them to access resources, directing them to another IT unit on your own campus who has a service that might meet their needs. Right now, we don't offer Windows, so if someone needs Windows support, where could that go? Something like that. The other point I'd mention is documentation and how important that is. Ideally, documentation is so that the researchers can independently find the solution by reviewing it. That isn't always successful, but somewhere where documentation can be really useful is having somewhere to point to when someone asks a question, say in our ticketing system. If we have it in our documentation, we can point them there and say, hey, go look, we have a very exact detailed answer posted here. We have an exact example of how to run GROMACS on our system, how to run NAMD, how to run MATLAB, ANSYS, whatever it is, so that there's something there, and putting the time into making that documentation, which is a huge investment. We've been fortunate, we've had some student assistants work on it over the years who've been great at getting that put together and updated, and most recently testing it to make sure it was still valid after some changes on our system. And that makes a huge difference with addressing those needs. I did want to comment on the last question about the useful length of a workshop. I wish I knew the answer to that one. It's a really great question. I think most of our just sort of standard workshops are about 1.5 to 2 hours. That's usually decent, I think, for if you're trying to get someone to sit down and just do something straight through. I tend to think longer than that's not very helpful. We did recently have an engagement with MathWorks where they sent an engineer to teach a workshop for a full day. And they were coming into our campus, so we had to do it all at once. And trying to get grad students primarily to spend a full day doing nothing else is tough because they have all sorts of other commitments. And we had a little bit more success when we tried breaking it up into 2 half days, because it can be a little bit less intimidating of trying to find such a wide block of time when someone's available. But you can go into a lot more depth with that full day workshop than you can with your 90-minute workshop that you might have otherwise.
Since the trainings were brought up, I just wanted to ask if in any of the campuses, is it mandatory to have a introductory training before they start using the local HPC center? Is it common? Is it happening at your campus? Yeah, I just had that question.
In my institution, it's not mandatory, but we provided the training sessions and uploaded the training videos on our website. So once the user getting the account, they can browse through our training sessions and get habituated. And they can, if they have come up with, if they have any other questions or issues, they can always contact us.
We've discussed it that as a possibility at Rice, but we weren't quite sure how to go about it. I do know that there are some institutions that function that way, where they don't give you an account until you've had an opportunity to sit down with the facilitator, and the facilitator walks you through the points you out where the documentation is and gives you a general orientation.
So without an actual cluster on our campus, we obviously don't have mandatory training. But what we do is at the beginning of every school year before classes start, we do have an overview session on a broad offering of different research computing things that we do on campus. And that just kind of puts it in people's mindsets what might be possible, especially for new incoming faculty. And then throughout the year, our approach, and this is one of the advantages of being a small institution, almost all of the rest of our training is on a one-on-one basis, where we're able to just work directly with individual researchers and train them on the specific resources they're using on an as-needed basis.
I guess we're sort of the opposite scale. We don't have the capacity to do one-on-one training with every new researcher who joins our cluster. We do have an orientation workshop. We did have at one point certain departments that were making it mandatory for their students if they wanted to use our system. That wasn't super enforceable and I think went away. So we make it optional. We offer it every 2 to 3 weeks, and we've also now got a recorded version of it, which we got a lot of requests for. That's really helpful for those with ongoing scheduling conflicts, who are traveling, anything like that, to make it easy for someone to get that overview, how to get started on our systems. That makes a big difference. And I guess, we do that in group sessions though, rather than, one-on-one. I know there are fairly large models like the Open Science Grid that do meet with every new researcher joining their system. And I'm really impressed they can support that. It's something that takes a lot of, time that has to be available for it. I will say we are talking for our instructional cluster side of things. Currently, we will meet individually with professors and TAs, and then we expect them to train all the students in the class who are using our systems. That works well when the professors or the TAs are well informed about research computing. It can be more challenging if they're less familiar. We're sort of starting to play with other models, see what sort of more direct training we might be able to offer going forward.
Thank you. Thank you. So we'll move to the next question. Let's see. Well, there we go. Okay, so for instance, when a researcher comes to you with not only a problem, but also has a proposed solution, do you prefer to start implementing their proposed solution right away, or to think about alternatives before implementing anything? If you could give an example where you have gone through this.
I can.
Okay, so yeah, Ashley, you can continue.
Oh, you can go first. It doesn't matter to me.
Yeah, so I mean, whenever we see the researchers also coming with the solution, so we need to see that solution, what kind of problem is that, and is the solution is a permanent solution. So sometimes the solutions might be temporary. It's not actually resolving the issue, but it's actually abating the the symptoms. So that's not then the solution is not very helpful. For example, we had when we had our previous cluster, we see lots of problem using the VS Code. So some users using the VS Code to log in to the clusters, and sometimes the login nodes hangs. That's kind of becomes unresponsive, and user complaining about that, because they also sometimes run the code with the VS Code, and they are doing this on the login node. So on the new cluster we we limit the CPU usage and the memory usage per user, and we also have remote and we also install VS Code CLI for with that they can use the JavaScript to run the VS Code on the compute node via Slum, instead of use the VS Code from their install their own computer. So this is actually helpful, but sometimes the user don't want that, because if they use with the Slum, then sometimes they have to wait. However, we also have the debug node or debug partitions where they can use a VS Code CLI using Slum for 8 hours. So yeah, so that is one example that just came to my mind about the VS Code. So user sometimes having the troubles with connecting the VS Code to the login node, and the user come up with a solution. Okay, I just need to clear some cache files from my home directory, and now it's working, but that is not the permanent solutions, because in future they might get again the problem with the VS Code with the login.
Okay. So when a researcher comes to me with a problem and a solution, do I implement this solution right away? I think it depends on who the researcher is, and if I have experience working with them before. I like to say that researchers are really good at ideating and visioning, not so good at implementation. at least in my experience. And so it really will depend on the researcher, how technical they are, how much time they have spent researching the problem and then finding the solution for that problem. And so and whether or not I need to do my own research or identify some other people to help me do research on the solution. Typically, what I am working on are more strategic and political issues with related to data set acquisition. So figuring out where is the blocker? Is it with our office's sponsored programs? Is it with data security? Is it with research compliance? Is it with the data provider? So usually we're working with state governments and requesting data from state governments so an example is the Pennsylvania Department of Health. We might need some of their data from their information systems to answer the question, how does involvement in the child welfare system impact long-term health outcomes? So we can request some of those data records to answer that research question that we are funded to answer. But there's a lot of issues with actually getting that data. It's easier said than done. So not always implementing right away what the researcher has asked me to implement, but sometimes working together with them and on maybe it's not feasible what they want to do, so we have to come to some compromise.
I would say in my experience, I think I kind of agree with what Ashley said. Some of it depends on the researcher, and maybe how established their processes are, and how much of a expert they are with their own sort of computing decisions. I mean, we often say that, one of our chief roles as facilitators is to help our researchers make better technology decisions. And so, there's a lot of times where, particularly if you have a new faculty member coming in with, startup money, or, they have big dreams, right? And they often I found myself, sort of talking them back from major expenditures or major commitments to infrastructure, because having seen the timelines that are involved, we know that there's going to be delays procuring things. It's going to take a little while for them to get students into their labs, students that are able to actually really start using the equipment that they purchase. And so you don't necessarily want to buy a whole bunch of gear up front, right? You kind of want to establish your workflows and make sure that your code's working, make sure that you're on the right track and then identify the bottlenecks before you start throwing gear at them. So we tend to try to take a conservative approach with our researchers, often when it comes to either getting compute condos within our shared HPC environment, or if they're buying their own equipment, or if they're making a commitment to, a large scale project of some kind. And we try to get them to leverage as many of our resources as they can. A really common example would be somebody who comes in and says, well, I need all this data storage, so I'm going to go buy a file server. And then our administrators have to run it for them and have to watch for the disk failing and everything else. It's like, we've already got a giant file server on campus. Why don't you just use that one? But then there's the issues of control and cost and all those kinds of things that have to be negotiated. So usually my approach is just to try to listen to what that is that they're trying to do as best as I can, and then sort of see where, okay, maybe they're over engineering this a little bit, or maybe it's completely reasonable. And then seeing what we have in-house that can help address what they're trying to do. and then, go from there after that. So I tend to be, like I said, I tend to kind of be on the conservative side when looking at solutions. Look for the simplest, cheapest stuff first, and then, and then if you run into constraints later on, it's to me, it's easier. It's a good problem to have to be able to have to scale out your resources because your problem is getting too big for the infrastructure. It's a bad problem to have a bunch of infrastructure that you bought that isn't being utilized. So that's kind of my take on it.
I agree with all the other panelists. And when a researcher comes to me, I find that even if they think they have a complete answer to their problem, there's sometimes almost always some aspect of their project that they haven't considered. So it's really worthwhile talking with them, understanding their workflow, and being able to bring the experience that we have as IT professionals to look at it from different angles than they're looking at it as a researcher, and just kind of fill in those gaps and make sure that there's something that's going to be the right solution for everything. And almost always we find out that while there might be some components of that original proposed solution, it almost always gets better through a process of reviewing everything and just thinking about it from all angles.
Actually, so the point that Clinton was trying to make, Dana also has an example where so somebody who came to them with a $50,000 budget for something was reduced to $500. That's fantastic. Yeah. All right.
Pretty
So
good.
yeah. And she adds that, so on the same question, that she tries to give two extra options, alternatives other than what they have come up with, which is remarkable, and speaks of the experience. So yes, over time, I think, yeah, we can give more options. All right, so we'll move to the next question. Clinton, do you want to add something?
Yeah, I was just going to add one more thought on that, and it kind of goes a little bit with what Ashley was talking about with like restricted data and things of that nature. Like I've run into situations where we were working with a researcher who wanted to deal with some restricted data sets, and we do have a facility that can handle that, but it's a fairly narrow scope of research, and it's really kind of dedicated to one particular research group. And so we're in many cases we'll say, look, the solution isn't here. Because if they're partnering with another, like a hospital, for example, in some cases, it's like they're going to have way more expertise with dealing with, patient data, for example, than anything that we can do here on campus at Rice, because we don't have a medical school. We don't have that kind of infrastructure. And so a lot of times the solution is really somewhere else, and you have to be aware of that, and not necessarily, I have a tendency to want to do everything in house sometimes. And I have to kind of fight that off and say, oh, no, this may not necessarily be our, we can help and we can advise, but we may not necessarily be the people who are going to end up doing the work on our end. So I just wanted to add that too.
Thanks. All right, so we'll move to the next question. And let's hope I can do it. Okay, so it's how often are you called on to help with research computing systems and services that another organization or institution provides? And what do you do in those cases? I believe this could imply things like the NSF services, I guess, access and things like that. And if you could give examples about it.
So we do this all the time because those are the only resources we use. And so basically we give a very white glove service. And if we're recommending someone look at another institution's resources through Access, we're going to help our faculty and our students every stage of that way, from requesting access credits to transferring those credits, how to then log into those systems. A lot of times we do that by pointing them to some of the instruction materials that those other organizations have developed. But there are questions and roadblocks that come along the way. And we just really want to make sure that our users know that they don't have to be the ones reaching out to these other organizations, because they might not know the right questions to ask. Instead, they can come to us and we can help do that kind of translation and kind of try to expedite the process on that.
I would say for us, it's actually less than you might think. And we have plenty of people on our campus using Access resources, using DOE resources, other things like that, but they don't necessarily think to come to us. And that's something we need to communicate more. And it gets into some other challenges that I think will be addressed later of how do you communicate your availability, what you can support, that we're here, we're ready to support people using Access systems, but people think of us as those people who manage the campus cluster, and they don't necessarily know that we can also help them with other things. Now, sometimes people come for support with all sorts of other IT services, and sometimes I try to give some basic help, but often don't really know the answer because they're not services I manage. And I think the key there is often sending someone in the correct direction, so that it's not, oh, just go ask for IT help. It's okay, well, there's this service, they made this change to it recently. So a lot of the people on our campus who use the VPN pretty much use it only to access research computing. And so when something changes with the VPN, we end up getting a lot of the questions about it. And knowing what's going on with the VPN, knowing where to direct someone when they need help, trying to keep up with that so that when they do come saying, hey, I can't get on the VPN this morning, you have some idea what's going on and where to direct them. Or sort of on the flip side, they want some sort of service that we can't host. So, Clinton was talking about locally versus centrally hosted system storage, things like that. We basically only do centrally hosted ones. And there's a lot of administrative push at our institution to make everything centrally hosted so that there's fewer of those other systems, but they do still exist. But knowing where to direct someone if they have questions about that, if they come saying, hey, I can't log on to the local cluster in my department this morning. Well, I don't have access to it. I can't fix that, but trying to direct them in the right way to get them somewhere. I would say the other part of though is like talking about the national resources, having that in our pockets to recommend when someone needs something that's not something we can support. If they need some sort of specialized resource like Jetstream offers, that came up. If they just need more resources and maybe don't have the funding in the right format to be able to purchase services from us, they might be able to use Access more generally, things like that.
Yeah, to add on to this conversation a little bit. So where I was located when I was doing facilitation was directly on a researcher team. So I wasn't housed in our computing center or in IT or anything. And so I didn't own any of the services or really, so I was really facilitating. And I like what Mike said, Michael and Tom, is you're translating a little bit, so you're helping the researcher ask the right questions, because the researcher's mindset, they're in their disciplinary domain scientist expert brain, right? And then we're having to translate between that brain and then the research compliance brains, or the technical brains. And so taking that question from the frame of reference that they have and translating it or asking that question more effectively is a lot of what I was doing. It was always very frustrating for me when a service didn't have good documentation. So whoever mentioned documentation, yes, it's so important. And I love when communities have really effective documentation. So folks don't even have to call you to ask a question. It's self-service. Unfortunately, I think a lot of times in higher ed, we don't budget for documentation time that's user-facing or user-oriented. So that was always a difficult pain point. And what would happen, or there's documentation, but it's not oriented towards a researcher for like virtual machines, for example. So I would have to kind of learn what the service is, the ins and outs, communicate with the service provider or owner, and then develop documentation for the research team, the researchers I was working with, or for myself in some of my direct reports, so we could communicate effectively with the researchers. So it was a lot of translation, I would say. Yeah.
I was thinking of an example, a couple of examples that we run into from time to time, which involve faculty moves from one institution to another. And when they often their data is moving with them, right? So um, we often have to interact with the either if a person's leaving our institution going to the new one or the other way around, they're coming from another institution. We're dealing with that other institution's research support folks, or maybe their central IT. A lot of the times when we're dealing with these situations, it involves some kind of data transfer. Um, and that always can be technically tricky, even with tools like Globus, because you don't necessarily know what the infrastructure is that they have on their side. Um, and in one case, we had a very high profile faculty member who left our institution and brought with him a whole lot of secure data with a lot of, very carefully curated corresponding IRB protocols and all the other kind of stuff that went with it, data use agreements, and me as an infrastructure guy, primarily getting tangled up in that was real education. um, and yet we spent a lot of time helping the other institution to design the system that faculty member was going to use in that environment, and it's sort of explaining what the challenges were and things like that. And one of the things I found really refreshing was how collegial the relationship could be. And it was and the shared knowledge, there wasn't, and leaving, I feel like I wanted to say this because I think that, like, even if you have a faculty member who's leaving the institution, um, there's a commitment there that continues on, both sort of on a kind of a personal responsibility level, but also on an institutional level. And so a lot of times we have to, I continue to treat those faculty members, as though they're still in at our institution, and try to help them out as much as I can without overextending our own resources.
Clinton, if I may ask, so such a faculty, the example that you gave, can they take an equipment out of the university? Is that possible, or that's not an option?
Typically, they haven't, but in some cases they have. I know that it's permitted in some situations because often new faculty that are arriving bring their equipment with them. And that is something that I wish would never happen, but but that can be really, really challenging when they show up with a bunch of old gear that the other institution is sort of laughing on the other side. We finally got it out of our data center, So so we run into that situation sometimes. And we have actually transferred in some cases equipment that had been bought with a grant that it goes with the faculty member, and we'll help usually to ship it at the cost of the new institution. We'll ship that equipment over. So that situation does come up from time to time, whether it's a system or whether and data ownership. And in many cases, we have they still have students at our institution that need to work with the data for a little while until they can either graduate or move if they're following their PI to the new institution in some cases, or if it's staff or research scientists, it can get pretty complicated.
Thanks. Ashley, is there anything in the chat that needs to be discussed?
No questions right now, just chatting.
Okay.
And I'm just aware of time too, so we might, I don't know, move on to the next question, or maybe if the audience has specific questions for us, I'm not sure.
They can be in the chat, or if somebody wants to unmute and ask, that's fine too. I think we'll move on and hope something comes up in the chat.
That sounds like a plan.
Yeah. All right. So I cannot get this thing to work. Okay. So having talked about issues, there's on the same lines, how often are you called on to help with issues other than research computing systems and services? What do you do in those cases? I think Michael talked a bit about that, and if others have experiences of that kind.
Well, I had one experience with that. So where we are generally, as a research computing facilitator, we mainly help with the users, to resolve the problems while they have while using our clusters. But one case I remember where the PI needs help to parallelize their code. So they they already so the code is already there, but the code is serial code. So they need they're asking for help whether it is possible for research computing facilitator to continuously work on the project and based on that parallelize the code. However, we kind of have shortage of research computing facilitator because we are mainly occupied with dealing with the user issues and also preparing the user materials. But if a research computing facilitator is totally devoted on working on the project, so that means this facilitator will not be able to do the other work. So yeah, but ultimately it's about how the things will be managed. But ultimately, the researchers, the PI finally found another students. Fortunately, so he just went on with that and then hired the students to parallelize the code. I'm not sure whether any of your institutions has this type of options where facilitator can also be part of particular project.
So I liked how Michael addressed this earlier. If it wasn't something that he could answer, he talked about how he directed them to the right people. And I do see that as kind of our role, is just knowing who it is that does support those other areas and make sure that we get our clients in touch with those people. Personally, there's a lot that I can do to help because I do have a much more broad role. So I do take care of a lot of things outside of research computing and can help people with those. But I do know those people that can help with those other areas. But one other thing that we do is we really listen closely to some of those requests and asks ourselves, maybe we aren't supporting that right now, but maybe we should be supporting it. And a really great example on that really came with code review. And so we would constantly have issues where people were just coming to us and telling us, I'm trying to run this code and it's not working. And that's a horrible position to be in as a facilitator, because you don't know right off the top of your head why it's not working. It could be a problem with how the software is installed. Maybe there's not libraries that it depends on. Maybe it's a problem with the hardware that it's running on, or maybe it's a problem with the actual code. So we were finding that we were having to do some level of code review anyway. So we just incorporated that as part of the services that we offer now. And so we will give people the opportunity for us to look at their code, see if there's any errors in it, see if there are ways we can help optimize it. And probably the most important thing we do is we teach people to comment so that we can read it later on when they come back to us later.
We have this problem come up fairly often for a variety of different reasons, and one of them was that a lot of our IT, I mean, I'm sure this is true of many institutions, but a lot of our IT was grown organically at the departmental level, um, such that, when I started working at Rice, I ran a server that ran email, the departmental website, backups, home directories, SSH gateway, authentication, um, and it was a file server. And it was a Sun Ultra 5, I think. So to give you an idea of how packed in all these services were, and a lot of that still exists in portions of our not necessarily our shared core systems, but some of the field systems that we support still have this kind of departmental model. And there's departmental data and research data in the same systems. It's a very gray area that can cause a lot of problems. The other place we run into this is where we do classroom support on our clusters, because if you want to teach parallel computing techniques in your class, then it isn't necessarily a research class, right? It may be an advanced computer science course or something like that, and we support those. So we occasionally get into the world where we're supporting, what would normally be supported by our learning environments team at Rice. So because we have the facilities to do it, and they typically don't, they don't have things at that scale. So because you run an HPC shop, or because you have access to GPUs, or because you have the expertise, sometimes you get called on to do things and work with things that are a little outside of traditional research. It isn't a huge part of our jobs, but we try to take it in stride as much as we can and be helpful. But it's very difficult sometimes it's still in many of our departments. There's stuff running in, systems running in people's labs that the whole department's dependent on, and that it isn't as bad as it used to be, because we've lifted a lot of those services out, and our central IT is managing things like email and calendaring and things like that, and all the productivity software, but it could be a real nightmare. So, as a cautionary tale, don't let that happen to you.
Yeah, so we actually, I think years ago, did have classes using our research cluster, and that was pretty messy. So it led to founding a completely separate instructional cluster for that purpose. And it was lessons learned from trying to support it on the research side that showed why that was necessary. It's been really successful. It's grown a lot, actually, really growing a lot lately. We have more and more classes every year that are taking advantage of the ability to have research computing type resources available for education. So it's an example of, but I think it was, I can't remember who was mentioned this, but I think it was Clinton or Tom, about when there's something you can't support, keeping that in mind for what you could support in the future, how to have a solution so you could say yes to that, what that would look like. And with the case of our instructional cluster, that's been really helpful to offer a lot more support and to make it easier when a class wants to use research computing type workflows, they can just get started right away on a service that already exists.
Yeah, I agree with that point as well, is, adding items to your roadmap. So you're working towards something and collecting feedback along the way, like what are the requests that you're getting, and what resources do you need, like financial and people, to support that capability or service, so then you can make an ask of your leadership.
That can be really tough in situations where you have there's a demand for general service. Like we have people asking us all the time for some sort of like VDI type of environment so people can have sort of virtual desktops that they can just connect to. And it would be incredibly valuable for research. It would be incredibly valuable for just non-research functions as well. But because of the cost and the IT overhead, there's sort of, everybody's pointing at the other IT department to say, no, that's what you guys are supposed to do. And I would like to see more, I would love to see more cooperation inside of IT organizations where they can, you know, they can develop services like this that add value to research computing just as much as they add to, sort of the administrative and other functions. But it gets to be a little bit of a resource war inside IT organizations sometimes.
Clinton, and to kind of build on that point a little bit, one of the great things about this entire process is it's all about building a relationship between the cyber infrastructure facilitator and the researcher. And we think about it a lot of times as what can we provide the researchers? But it's really a two-way street too, where the researchers can also be some of your best advocates to help get those discussions going on the funding and the staffing. And they can get a lot more headway in those areas than anyone from IT would ever be able to get on their own.
Yeah, I mean, I agree with what just Tom mentioned, and what sometimes we have noticed, for example, some users are asking for how to effectively use their software. For example, how to run effectively GROMACS or any other type of open source software there. So sometimes as IT department personnel, they may not be aware of this particular software, and it's really up to the researchers, because some researchers, they really know, I mean, they're really knowledgeable about this type of software. So we are kind of planning to conduct some kind of open meeting, based on the particular how to effectively use special software and what kind of practices they need to follow, so that the researchers who are mainly experience using their software, they can actually provide some examples and talk about that. So this will be really helpful to the new users.
Michael, the thing that you mentioned, that you have compute resources for classes versus the central HPC thing. So is it the resources for the classes, are they for a particular department, or it's also a central facility that anybody can use?
So it's also centralized. So the same team of us who manage the centralized research computing also manage the centralized instructional computing. That said, our College of Computing, which is like computer science and similar majors, does have some of their own stuff as well, especially when they want more specialized resources that aren't quite ready for sort of enterprise research computing type services yet. And historically, they ran more. They actually merged a lot of their equipment into our centralized one. That was a lot of how we were able to get started with a centralized resource, was taking what our computer science students had and building on it so that students from all across the institution could have access to it. I mean, it's heavily, I say, computer science and electrical engineering courses are still, most of it. But we have seen it growing. We've seen the occasional business school course, things like that have shown up wanting something that we can offer. And the other advantage of having it centrally is we try to keep it as similar as possible to the research side, which makes it easier to manage. It's using the same sorts of hardware. It's actually on the same network fabric. often parallel storage systems so that we can use knowledge and expertise from one on the other and simplifies managing it.
So I think we're at time. I think our session goes to 3:45, so we're technically a little bit over. Nandin, I don't know if you wanted to close us up.
Yeah, I think we have gone through all of the questions except one more, but yeah, we are fine. We can skip that. And yeah, thank you to the panel for sharing their experiences and wisdom. And thanks, Henry, for having this session. Back to you, Henry.
All right. Thank you all. And let me stop recording.